Welcome everyone. We are picking up where we left off, so we are now going to be doing notes on combinations. So this is the last section of this unit. You should be on page 2F because that's the last place we need to do. And this is a very short podcast just because it's the last part and there's not a lot to do here. Okay, and so we've already done permutations where the order really does matter, so you really have to pay attention to that. Now, in this particular for combinations, in this particular one, the order does not matter. So let's write that in. So order does not matter. And you'll see what we're talking about when we do some examples and where it matters and where it doesn't. So what we're going to ask is here, we are going to find the number of ways you can purchase 3 different kinds of cheese from a selection of 10 cheeses. Now, it doesn't matter which cheese you pick first or the order you pick the cheeses in, so you can use the formula for combinations. Now, on the calculator, it looks like this, and we've talked about that. So it's n objects taken 3 at a time. Okay, so again, 10 objects taken 3 at a time, and so n is 10 here. And so this would be the formula. And so if you're looking for the generic, because you don't have that, it's n factorial over r factorial times n minus r factorial. Make sure you put this in parentheses on the Casios, put that multiplication symbol in, and you'll get that answer. So when you work this out, you see that there are 120 ways to purchase 3 different kinds of cheeses from a selection of 10 different kinds. So when you're reading the problem, the first thing you've got to determine is it a permutation or is it a combination? That's what you need to figure out first. And so let's go, and again, there's not much here, so we're going to go straight to some examples. And so on the next slide, as soon as it clicks over, we're going to use an answer and see kind of what we're doing. So it's a permutation or a combination. So as you see on number 1, it says how many ways are there to choose a committee of 3 people from a group of 5 people. And then number 2 is how many ways are there to choose 3 separate office holders, chairperson, secretary, and treasurer from a group of 5 people. So for number 1 above, the order doesn't matter, so it's a combination. So we would be doing 5 people taken 3 at a time. And when you plug that in on your calculator, you should get 10. Okay? So, and again, you just plug it into the formula that you saw on the previous screen. And so for problem number 2, though, where we're looking at the office holders, the order does matter because you're needing a chairperson, a secretary, and a treasurer, so it really does matter. So this is a permutation. So then here you're going to do, and let me go ahead, sorry, here and write the formula out. And so then it's going to be 3 factorial times 5 minus 3. Whoops, sorry about that. Let's undo that. Okay, so 5 minus 3 factorial. I'm not sure why it's acting like that. All right. And then for the second one, we're actually going to use a permutation because the order does matter. So here it's 5 with a P and then 3. And so what you're going to get is you're going to get 60 when you enter that. And remember, that's going to be 5 factorial over 5 minus 3. I am not sure what is going wrong with my equipment. Sorry about that. It's like almost like it's not catching up. So sorry about that. Catch up. Okay. So it's 5 minus 3 factorial. All right. And so that takes care of that. So that gives you an example of how to kind of determine does the order matter or not. So we're going to go to the last slide, and this is just practice. So what you need to do is determine what they are first, and then you can just plug them in. And so what you're going to do, we're going to read through this. So the first one, if you notice, it doesn't matter which one. So this is a combination, and here it doesn't matter. This is a combination. This one does matter. It's like the previous one, so it's a permutation. And then here, this one doesn't matter. So it's a combination. And so just putting in some numbers here, I'll just plug in the answers. You should be able to get those okay. But let's do the first one. So it's 9 taken 4 at a time. And so this one I got 126. Double check me if I made a mistake, please let me know. And then you have 12 taken 3 at a time. and then this one's 220. Again, I have no idea what's going wrong with this, guys. I am so sorry. Um, I'll go and check on that. And then for the third one, you have a permutation, so 12. And then make sure you're hitting the right one, whether it's a P or the C. And so this one is 1,320. All right. And I'll get that checked out. And that's supposed to be a 0. Again, I don't know why it's doing this. And then for number 4, that one is 32. It's a combination taken 12 at a time. And it's a really large number. Okay, so looks like you're in the millions. So that pretty much takes you through that. We should be able to finish this up unit no time, and I am planning to test next week. So you'll watch your podcast, and then we'll start checking answers and looking at different ones and seeing what we have. All right. So thank you, and we'll see you on the next unit.